Hello and welcome everybody. This is a quick tutorial on how to use the quadratic formula. So this could be for your algebra class or it could be for your geometry class. So, it's up to you whenever you see it. So here, what I did was I wrote down the quadratic formula over here, and we're going to go ahead and do some examples as to like how to use it in just a little bit. So the idea is that if you have a polynomial where you have ax squared plus bx plus c is equal to 0, then in order to solve for x, then according to the quadratic formula, is supposed to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, some of you guys might have ran into it back in middle school, and that's totally fine. Hopefully this is something that you guys remember, but if not, then let's just go ahead and refresh it. Now, underneath right here, you'll see that I have a whole bunch of, looks like chicken scratch, but basically it's the proof of the quadratic formula, so then that way you can see that I didn't actually pull it out of thin air. If you want to slow down the video or pause the video so you can take a look at the steps by step, the left-hand side is kind of the algebra work, the right-hand side is the reason. So hence, statement and reason. You can see how this is actually going to be derived in. And this is definitely not the only way of deriving it. There are other ways, but this is probably one of the more traditional ways out of 350 ways that are available. But anyhow, scrolling down right now, because we're not going to talk about like how it's derived, but rather how to actually use it. Let's go ahead and look at an example of a problem where you will have to use the quadratic formula then. So in this first example over here, you have x minus 3 divided by 2 is equal to 6 divided by x minus 2. And this is what is known as a rational equation because you have a fraction on both sides where x is in the numerator and you can see x is also in the denominator. So the first thing that we do for this rational expression, so then that way you can see where the quadratic comes in, is we're going to go ahead and multiply both sides by cross multiplication. So taking our equation right here, we're going to go ahead and multiply everything by 2. And then also multiply by x minus 2, okay? So then that means we now have x minus 3 on the left, multiplied by x minus 2, and that is going to be equal to 2 times 6. Now, this is the part where we cannot solve for using the quadratic formula yet because, remember, the quadratic formula calls for the right-hand side or the left-hand side to be equal to 0. Unfortunately, right now it is equal to 12 because of 2 times 6, so we have to do a little bit more simplifying. So on the left, we're going to go ahead and multiply this out by using FOIL. So this multiplied by this will give me x squared. This multiplied by this will give me negative 2x. This multiplied by this will be negative 3x, and this multiplied by this will be equal to positive 6. And all that, it is still equal to 12. Keep trimming it as much as you can. So x squared minus 5x and then plus 6 is equal to 12, and we're almost there. We're going to go ahead and move that 12 over to the left-hand side. So x squared minus 5x and then minus 6 is equal to 0. Now, at this point, you can actually use a quadratic formula, which I will show you in just a little bit. Or if you remember how to factor, that would actually help out too. So if you're thinking about factoring, because I think that would be a little bit easier if, factoring is a possibility in here, what we do is we look at the two numbers that are over here, negative 5 and negative 6. We ask ourselves the following question. What two numbers adds up to be negative 5, that number in the middle, but at the same time multiply out to be negative 6, that number on the far right? If you can give me two numbers that will correspond to this, then that means that we have something that's factorable. So once again, if you can find two numbers that adds up to be the middle, which is negative 5, and at the same time multiply out to be negative 6, which is on the right, then that means that this is factorable. In this case, the numbers that I'm looking at would be, let's see, how about, I don't even know. Okay, how about negative 6 and also positive 1? Ooh, almost very embarrassing over there, okay? So looks like negative 6 and positive 1 will give me that scenario where you add the two will give you negative 5, but multiply together will give us negative 6. So what that means is this will then factor into x minus 6 multiplied by x plus 1 is equal to 0. So therefore x is equal to 6 or x is equal to negative 1. So that would be the easy case scenario where if this is factorable. Now, if you are not sure if it's factorable because, maybe you just can't find the two numbers, you can use the quadratic formula. So here we can go ahead and write that out. So let me just go ahead and write on top the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. In this case, a is equal to 1, b is equal to -5, and c is equal to -6. So let's go ahead and throw it all in there. X is equal to positive 5 because it's -5, and then plus or minus the square root of b squared, which is 25, minus 4, multiplied by a, which is 1, times -6, which is going to be c, all divided by 2 times 1. Now, one common error that a lot of people do is that they include x in there for b and c and a, and you're not supposed to do that, okay? You're solving for x, so there shouldn't be x on the right-hand side. Everything should be numerical. So now we're going to go ahead and clean this out. So 5 plus or minus the square root of, in the inside, I am seeing 25, and it looks like it's going to be plus 24, all divided by 2. Well, fortunately, it comes out to be 49 if I'm looking at it correctly. So 5 plus or minus the square root of 49 divided by 2. And so x is equal to 5 plus or minus 7 divided by 2. So in one case, the positive answer, 5 plus 7 divided by 2, which is equal to 12 divided by 2, which is equal to 6. And that's definitely one of the answers that's over here. In the other case, it's 5 minus 7 divided by 2, which is equal to -2 divided by 2, which is equal to -1. And you can see that answer as well over here. So either way should be okay. Factoring definitely is a lot easier because then you don't have to go through the grinding of getting the numerical value like this. So let's look at one last example over here where again you have a rational expression and you need to solve for x, and most likely by the quadratic formula. By the way, hopefully this is something that you will recognize, is that at the very bottom of this, because x is in the denominator, this tells me right off the bat that x cannot equal to -1. And sometimes that is going to be a factor because when you solve for this and you get x is equal to -1, then what that means is you have to not include that as your solution because it's what is known as an extraneous solution, meaning that you cannot include it. Just because you solve for it doesn't necessarily mean that it works. But anyhow, enough of that little Algebra 2 snippet. Let's go ahead and solve for this. We're going to go ahead and cross multiply just like last time. So I'm going to multiply both sides by 5, multiplied by x plus 1. So that would give us x plus 2 multiplied by x plus 1 is equal to 5 times 3. Multiply everything out, x squared plus, let's see if we can do this a little bit faster, 2x plus x, that's equal to 3x, and then plus 2. And all that is equal to 15. On the left, I still did a FOIL, but I probably did a little bit faster because, we want to speed this process up as possible, right? You don't want to keep doing FOIL every single time when you can kind of build up your speed. All right, next, we're going to move everything over to the left-hand side. So then that way we can have something is equal to 0. So x squared plus 3x minus 13 is equal to 0. Think to yourself, is this factorable? Meaning, can you find a number that adds up to be positive 3, which is that middle number, and at the same time multiply out to be -13? The answer, unfortunately, is no, because there's no whole number that's going to make it work. So what that means is we're forced to use that quadratic formula in this case then. Okay, so let's go ahead and finish it over here on the side. So x is equal to, let's see, writing it out again. A is equal to 1, B is equal to 3, and C is equal to -13. And if you're wondering where that A is equal to 1 is coming from, you can think of it as an invisible 1 that's multiplied by the x squared. So x is equal to -3 plus or minus the square root of 3 squared. So that's 9 minus 4 multiplied by A multiplied by C. Okay, all divided by 2 multiplied by 1. So x is equal to -3 plus or minus the square root of 9, and then it looks like it's a plus now, and that's going to be 4 times 13, which is equal to 52, all divided by 2. So let's see, 9 plus 52, that's equal to 61. And I think that's where the dead end is going to come because unfortunately we cannot take the square root of 61, nor can we factorize it. So then that way it'll be cleaner. So then that means that these two will then be my solution. Okay. One final thought is that also we want to go back and think about if what we solve for are going to be extraneous solutions. Meaning, for example, if you were to solve for this problem and x represents, like, say, a distance, then you can't have x as a negative number. So always want to go back and check your work just in case. All right, thank you so much for watching. I will see you guys next time. Goodbye.